The Alpine.js framework is pretty awesome, and part of what makes it awesome is that the syntax for consuming it in the context of the HTML markup is pretty seamless. We can call methods, we can reference objects and properties on those objects, we can have expressions here that evaluate to truthy falsy stuff for our xifs. In our counter, in our click handlers, for example, we can do multiple statements separated by semicolons. We can even have console log statements inside our click handlers. And all of this is made possible because under the hood, Alpine is basically taking your expressions and just evaluating them in a JavaScript context, which is really great in terms of the overhead and the performance and the functionality. I think it's like a couple of dozen lines of code to actually make that happen. But it is not great in terms of security. And so if you have to comply with CSP, or a content security policy that prohibits unsafe eval, it basically breaks most of the Alpine.js ecosystem. And we can see this because they have a CSP version of their build which overrides the internal evaluator and essentially allows you to just look up things by key. And at the top here, we're going to include a meta tag equivalent for our content security policy, and you'll see that there is no unsafe eval being allowed. We just have our nonce, and you'll see down here in our script tags, we have the nonce here so that the browser will execute it. And we have a little demo app here. I have a try catch, and I try to do eval, and that's just to verify that eval is actually being blocked by our content security policy. And then I set up an app, and the app just has a couple of counters. Each counter has its own name and its own value. And then there's a method for incrementing a given counter and for resetting and logging the reset of a counter. And in our app here, you can see that we're using the X4 to iterate over those counters. We have our increment counter invoker passing in the counter name value. We're hiding a reset button until the value of the counter is greater than 0. And then you'll see we're doing an inline reset of that value here. We're not even calling a method. We're just directly changing that value, assigning it to 0, and then we're logging here. And if we go over to the browser and we try to run this, let's refresh, you'll see at the top here that the eval function threw an error, and that was our try catch here. So we can see that the content security policy is in fact preventing eval from executing. But then we can see that we get all these other errors because essentially none of this stuff worked. I don't even think we can't even call things. We can't log to console. We can't do anything. So the CSP compatible build is basically broken. I mean, you can do some stuff, but it's very, very simple what you can do. But I don't think it's going to work well for a lot of contexts. But you know who also worked like this? Angular.js. And Angular.js didn't have issues with content security policies. And that's because they actually build a JavaScript expression parser into the framework. So as a thought experiment, I want to see if I could take their parser and forklift it into the Alpine.js context by creating a custom evaluator. So if we come down here and let's uncomment this. So this is the code that I ripped out of the Angular.js parser. I'm calling it Angular Parser Lite. And if we jump into here, let me just show you, it is hundreds of lines of code. And it has a, let's see what you can see. It has a, where is it? It has a lexer. So that's the thing that breaks the string up into tokens, like an identifier and a dot and an operator and a parentheses and a closing parentheses. So that's the lexer. And then it has an AST creator, or an abstract syntax tree. That's essentially what takes the tokens from the lexer and builds it into a complex object that represents that expression. And then if we keep going down, we eventually get to an AST interpreter. So once it builds that abstract syntax tree, it can then interpret that syntax tree, or essentially evaluate the expression in the context of a given data structure. And all the way at the very bottom, let's just ignore basically all of this file. What we can see is that I am exposing this method called parse on this IFI, this immediately invoked function expression. And parse takes the lexer, it takes the abstract syntax tree creator. It takes the AST interpreter, generates the AST from the past and expression. So that's going to be the string that represents our expression. And then it compiles it with our AST compiler. And what that's going to do is return a function that, when invoked, will evaluate that expression. And you can pass to that function a scope and a set of local objects. All right, so that's what that is. And then if we uncomment, this is my Alpine CSP experiment. This is my overriding of the Alpine.js evaluator to use the Angular.js parser in the context of this application. So let's go ahead and refresh before we look at this code. And what we can see is that it loads the eval function still through an error. And again, that's good because that's being blocked by our content security policy. But now I can increment this given counter. You can see they're operating independently. I can reset it. I'm logging the reset. I can increment this one a bunch of times. I can reset that. If you remember here, this one has a direct console.log right in the click handler. And if we log that, you can see I'm able to log to the console. So I'm basically using a normal Alpine.js set of features, but I'm doing it inside of a content security policy compatible environment. And again, just if we look at the head here, you can see I have my content security policy working. So let's take a quick look at what's going on under the hood there. So here is my CSP experiment. I am able to do this because Alpine exposes this set evaluator function and allows you to pass in a custom evaluator for the application. This is what they do with their CSP compatible build. They essentially pass in a CSP compatible evaluator. And I'm just doing the same thing, except I'm implementing it on top of the Angular.js parser. So here's our experimental evaluator. This gets called for every single element and expression combination. So every time, actually we can just see this. Let's just console.log element expression. And if we refresh, you'll see that it's getting called for every single one of these expressions on the templates. So that returns a evaluator. So we take this expression, we take this stack, this data stack out of the DOM, and we return an evaluator function. This is the function that can be called by Alpine.js to evaluate the expression. Of course, it's not evaluating the expression directly. We're doing that under the hood. And what you can see, I'll skim over some of this, but essentially we're creating an entire stack of data here, including the local scope, and that would be things like the X4 scope. We have the data stack that we pulled out of the DOM that we received from above. And then we have the window object. And that's why by adding the window object to the top of the data stack, I can do things like console.log because I can pull that off of window. Now here, when I take the expression, I need to generate a function, and I'm going to use that ng parser. So if we just jump down here, you'll see all it does is look at the cache to see if it already parsed this so that we don't have to parse the same expressions over and over again. And if it doesn't, it calls that ng parse that we discussed earlier. It passes in the string expression, and that's going to return that function that is able to take a scope and a set of local objects. And so that's going to return a function here. So this becomes a function, and then we evaluate that function using the Alpine.js data stack. That's essentially the merged proxies, if you will. That's the stack of data going up the DOM from the current element, and then the locals. And the locals would be things that the expression can use that are not part of the data stack. So again, things like the event object or the index in an X4, which is not readily available per se. That will result in something, and if it's a function, we can invoke it. This is just sort of part of how Alpine.js is defined to work under the hood. The real piece de resistance here is this line right here, where we're passing that string expression to the Angular parser. And again, if we refresh, we can see these operate independently. And if we look under the hood at the code here, I'm looping over the counter. So when I call increment, I'm invoking that method with this argument, and I'm passing in the counter So this is the iteration value for the X4, which is why whenever I call increment counter, I'm only incrementing the given counter and not all of the counters, or throwing an undefined error. So anyway, just a fun Friday code kata thought experiment. There is, of course, much more code here, right? If we look at the network activity, the Angular parser adds another 30K of execution code to the library, but it does allow Alpine to operate with much higher fidelity in terms of the original API while staying compliant with the content security policy. So that's pretty cool. Yeah, there you go.